So we introduced inverse functions to lead us to exponential functions because exponential functions are the inverse of logarithms. So in a couple of weeks, we will start talking about logarithms, probably a topic not a lot of you have worked with. Let's start here with exponential functions. Just a reminder that you have quizzes due this week and that you have an e-text you could be using for extra practice. So we have here our exponential function, f of x equals c times a to the power of x. For most of our introduction, we're going to let c equal 1, but let's talk about this. We have a base a. It's important that you always recognize that the base is what the exponent is affecting. Now, a has to be a real number. A has to be positive, greater than 0, not equal to 0. Also, it's important to note that a cannot equal 1, because if a equals 1, then we end up with an answer of 1 all of the time. C, that coefficient, has to be a real number. Let's look at some examples and see if we can identify the base for each of these functions. It should be pretty clear in the first two. You can see the base here is 4. And in the second one, we see that x is applied to everything in the brackets. So our base is that fraction, 3/4. Identify the base in the next three. Here, I hope you see that the base is e. That exponent x is only applied to e. 4 has its own exponent of +1. Now, in question F, you think it's not difficult, and yet I'm going to see some of you making mistakes where you're not identifying the base as the number to which x is applied. Did you find the base for the last f of x? Do you notice that this could be written as 3 to the power of x times 1/4? This x is only applied to the 3 in the numerator. There aren't brackets telling us to include the whole fraction. So this only has a base of 3. Make sure you're clear finding the base. We also want to talk about graphing exponential functions here. Now remember all of those key points you memorized for other basic functions, so we could apply the transformations. The same thing is going to apply to our exponential functions. Now you see I have a to the power of x written twice because each of these has a different restriction. In the first one, we have a is greater than 1. So for our purposes of graphing, let's let a equal 2. So we have f of x equals a to the power of x, where a equals 2. So now we want to evaluate using the values of x that I've given here and find y. So we're going to let x equal -2, -1, 0, 1, and 2. Find those values of y. I hope you are able to find these corresponding values of y. Let's plot those on the graph below now. So your graph should look like this, or at least the points that you plotted should look like this. We can, of course, connect these. And I hope you realize that as x gets bigger, x equals 3, we would go to 8, x equals 4 to 16. So we know that it's heading up towards positive infinity on the y-axis as x approaches positive infinity. But we want to know what happens over here. Does our graph ever reach the y-intercept? And if the graph reaches the the x-intercept, then we know that y has to equal 0. So the question is, does 2 to the power of x ever equal 0? It doesn't. Our numbers get smaller and smaller as x gets smaller, but we don't reach zero. Do you remember what we said when we were talking about rational functions? If a curve is approaching some number, our curve is approaching zero, as x approaches negative infinity, it gives us a horizontal asymptote. So we have a horizontal asymptote here at y equals 0. And our graph approaches that asymptote, but never touches it. Let's look at the other example. In this example, we're saying that a has to be a number between 0 and 1. Do you remember what we said about a earlier? We said that a has to be greater than 0, so greater than 0, but not equal to 1. So that gave us two intervals for our values of the base. We already checked a greater than 1. Now we want to look at those values of a between 0 and 1. So let's say that a is equal to 1/2. We're going to look at the exponential function. The f of x equals 1/2, and it needs to be in brackets, all to the power of x. I want you to substitute these values of x into the exponential function and determine the corresponding values of y. I hope you caught my mistake there. I was thinking about the answer. For the first one, x is -2, y equals 4. X is -1, y equals 2, and so on. Let's plot this graph. So you see that this graph is decreasing where the first graph was increasing, but again, we have a horizontal asymptote at y equals 0. Let's take a closer look at these two graphs so we can determine some of the properties of our exponential function. We'll do that in the next video lesson.